Okay, pre-cal, we're going to look at some functions and determine if they're inverses or functions and write them that way. Now, all functions have an inverse, but not all of the inverses are functions. So once we determine what the inverses are, we'll determine if they're functions and we'll state any restrictions in the domain. Okay, so this very first one here, we can think of this as y equals x minus 1 over x plus 2. So essentially all we're going to do to find the inverse is we're going to switch the x and the y algebraically. And this one's ugly because it's a fraction. So the very first thing I want to do is I want to eliminate the fraction. So I want to multiply both sides of my equation by the denominator. And what happens over here on the left is I have to distribute the x, and now notice that my y's, I've got a y over here and a y over here, and I need those on the same side. So what I'm going to do is I'm just going to manipulate this mathematically. Remember, you can do anything you want to an equation as long as you do it to both sides. So I'm going to subtract this y from both sides. So that leaves me with x, y minus y plus 2x equals negative 1. And now I'm going to subtract the 2x from both sides. And that leaves me with xy minus y equals negative 2x minus 1, or negative 1 minus 2x, it doesn't matter. Okay, so now that I've got my y's on both sides, I'm going to factor the y out so that I can push the x to the other side. So I'm going to divide both sides by x minus 1. So now I have my function here. And this is a function because it is going to be just like your reciprocal parent. It's just changed a little bit. So you do have a one of those reciprocal type graphs here. So we are going to write this as a function, an inverse function. It's the inverse and it is a function. Now, when we're looking at the domain is restricted here because I have a variable in my denominator. So I remember that I can't have a situation where my denominator is 0. So I need to find what values for x will make that happen and eliminate them from the domain. So if I solve this, oops, that should be a 1. If I solve this, x equals 1. That means the value that the domain can't have is a 1. Every other value in the domain is okay, but x can't be 1 because it will make the denominator have a 0 in it. Okay, so let's look at part B of example 3. I've got y equals 5 minus 3x over 2. Now, another way to think about this is y equals 5 halves minus 3 halves x. So if you'll think about it, this is just a line. So every line is a function. So let's switch out my x and my y and find out if the inverse is also a function. So again, I'm going to get rid of my denominator by multiplying both sides by 2. And then it's nice and easy. And then, of course, I've got to get my y all alone because that's what I'm solving for. And again, you end up with a line. So I have a function. I have an inverse. That's a function. That's why I'm writing it like that. And since I don't have any variables in my denominator, then my domain is all real numbers. Groovy. Okay, let's look at part C. All right, before we do part C, I need you to notice that you have a square root function. So this function would just be the square root function moved over to the right. Okay, so that's what that looks like. Okay, so I know this is y equals the square root of x minus 2, so I'm going to switch my x and y. And I don't want that square root, I want to solve for y. So in order to get rid of that, I'm going to square both sides. So I end up with x squared equals y minus 2. And then I'm going to add 2 to both sides. So my inverse ends up being x squared plus 2. Well, this is a parabola, so I know that it is a function. So the function, or the inverse that's also a function, is this right here. Okay, but stop right there. You need to understand that this, when we graph it, looks like this. Well, my original function is just this. So the only portion of this parabola that I need to show me the inverse is only the portion that is positive for the domain. In other words, I don't need this portion over here. I just need this portion because that is the only portion that is truly the inverse of this. I didn't draw it to scale so it doesn't look like it's the inverse, but just trust me. So your domain is restricted to only this half because that's the only half that's actually the inverse. So let me draw a better picture for you, okay? So if I've got this right here, okay, this, if I look at the parabola, I drew the parabola wrong, that's why it didn't look right. It's the parabola moved up 2, so see how those would be the inverses of each other. I'm only worried about the positive side. Okay, that's why my domain's restricted, because this piece over here is not the inverse of this. See how this is just half of a parabola technically? That's why you only have half of it as in the domain. Man, I'm getting tongue-tied. Sorry, kids. I know. Okay, for part D, I'm going to do the same thing. I'm going to switch my x and my y. And I'm going to solve for y. Okay, this time to solve for y, I have to take the square root of both sides. And remember what happens when you take the square root. You end up with y, but over here it's plus or minus x minus 4, because remember when you take the square root, it's plus or minus. Why is that, Miss Griggs? Because if you were to square both of those, the positive value squared is the same as the negative value squared. So that is the reason. Okay, so here we've got this right here, and I need you to note that, yes, the inverse is plus or minus the square root of x minus 4. But this inverse is not a function. That's why I'm not going to write it this way like I've written all the others, because this inverse is not a function. Why is it not a function? Because if I graph the positive square root of x minus 4 and the negative, see, this fails the vertical line test. So the inverse is this, but the inverse is not a function. So I have to look at my domain restriction. So this is x minus 4. 1, 2, 3, 4. So the domain of this is just positive 4 to positive infinity. There you go. Okay, and my last function, this is y, and this is x. So I'm going to switch my x and y again. So this is x. And this is y. Notice that this is the cubed root, so I'm going to cube both sides. So I have x cubed equals y minus 7. I add 7 to both sides, and I end up with y equal to x cubed plus 7. So that's the inverse. Is the inverse a function? Well, think about what this graph looks like. It is just the cubic function moved up 7. And that is still a function. So this is a function, And because we know the parent of x cubed looks like this right here and just moved up 7, my domain consists of all real numbers. Excellent.